Welcome to the 8th episode of the Grand Cosmic Story. What if our sun is given a choice to choose its place in the universe so that it can become a hope to us? What if we are strategically placed in the right place in our galaxy so that we can look around and understand our purpose of being here? Yes, indeed, our sun is located in the most strategic place where not only we can thrive but also have an excellent cosmic window.
Are you curious about the world around you? Do you wonder what else is out there beyond our world? Dr. Latha Christie, a scientist and an author, will take you on a journey through the universe. Join her in exploring the universe through her web series, The Grand Cosmic Story. Stay tuned to find out what today's episode is all about.
Have you read one of the famous children's stories, the story of Goldilocks and the Three Bears? I had read many times when I was young. This story is about a young girl named Goldilocks who stumbles onto the home of the three bears when she is taking a walk in the forest. She tries out 3 porridges, 3 chairs, 3 beds before finding one of each that fits her perfectly. Not too big, not too small, not too hot, not too cold. What if our sun is given the privilege to choose the right place in the whole universe and it has chosen the exact right place where life can exist, where human beings like us can live? This is the stark truth that somehow our sun has found its way to the Goldilocks zone in our galaxy. To understand this, we need to know the evolution of our galaxies and stars. Let me ask you a question. Why is our night sky dark? Why does the combined light of the billions of stars shining around us not add up to make our night sky and the surrounding space bright? This puzzle was put forth way back in 1823 by the German physicist Heinrich Wilhelm Olbers, and so it is called Olbers' paradox. The best resolution to Olbers' paradox can be presented in 2 parts. The first part is based on the origin and the expansion of our universe. The light emitted by distant stars and galaxies takes time to reach us, and since space between galaxies expands and stretches, the light in that space too stretches and shifts to longer wavelength. This makes distant objects very dim or even invisible. The second part of the solution to the paradox is based on the nature of the life of stars that make up the universe. Stars do not live forever like us, but they die in a much more spectacular way than humans do. Their lives last between 1 and 10 trillion years. Though there are many stars in our galaxy, we can see most of them at different stages of their lives. Many are dim towards the end of their lives, and this is the second reason that the combined effects of all the stars are unable to light up our night sky. How are stars born and how do they die? A star is born when an extremely cold cloud of gas and dust is clumped together by gravity. As gravity pulls the disintegrating cloud back, it becomes denser and denser, and the condensing matter begins to heat up. When the temperature increases to a few million degrees, nuclear reaction starts at its core, fusing hydrogen into helium and thus giving birth to a star. Stars are giant nuclear reactors. In the core of a star like our sun, energy equal to that of 15 billion nuclear bombs is produced every second. That is the reason for the heat and light from our sun. Also, the heat of powerful nuclear reactions in the star's core keep the star alive by producing enormous pressure to balance the powerful force of gravity trying to collapse the star. However, over time, as the star consumes all its fuel, which is hydrogen, the core of the star starts to shrink, while the outer layer starts to expand and slowly dissipate into space, and the star starts its journey towards its death. Every star that you see goes through a natural life cycle from birth to death. Next time you look up at the stars, You should remember this is how they were born and this is how they will die. In the 1930s, a young Indian physicist, Subramanian Chandrasekhar, applied special relativity and a new theory of quantum mechanics to a star. He warned that if the star surpassed a certain mass, gravity would squeeze it down much further, perhaps even to a singular point. Horrified, Eddington declared that there should be a law of nature to prevent a star from behaving in this absurd way. But there was no such law. Chandrasekhar had opened the door for other astronomers to contemplate the existence of the most bizarre stars ever imaginable. They found that a star more massive than our sun could face a violent death. When such a star runs out of its fuel, it gets heated up and starts to fuse carbon and oxygen into heavier and heavier elements and finally iron. Once the star starts to fuse iron, it starts to absorb energy instead of producing energy, and within a few seconds, the whole star collapses and explodes violently. This dying gasp of a star is called a supernova. It's a spectacular explosion that one can ever imagine, with the light coming out equivalent to that of the brightness of 100 to 1000 of suns like our own. This explosion blows off the outer layer of a star and the central region of the star collapses under gravity. There can be two outcomes of a supernova based on the mass of the collapsing core. It can either become a neutron star or a black hole. When the core collapses to around 2.5 times the mass of our sun, they collapse in such a way that the protons and electrons combine to form neutrons to form the most densest object ever known, called the neutron star. 1 teaspoonful of a neutron star would weigh 1 billion tons on Earth. This means a neutron star is so dense and small that it possesses a surface gravitational field of around 200 billion times that of Earth. Astronomers found that gold is generated during intense collisions of pairs of neutron stars. Gold has much larger atoms than carbon and oxygen, and that's why it cannot be made in the core of a star. On the 17th of August 2017, the Laser Inframeter Gravitational Wave Observatory in the US and the Virgo detector in Italy sensed 2 neutron stars for the first time, catching the last 2 minutes of their life as they spun thousands of times around each other before colliding. By studying the explosion, astronomers said that it had produced huge amounts of gold and platinum, much more than the entire weight of Earth. Neutron stars can also have magnetic fields 1,000,000 times stronger than the strongest magnetic fields produced on Earth. Pulsars are spinning neutron stars that have jets of particles moving almost at the speed of light above their magnetic poles, producing very powerful beams of light. Pulsars often look like flickering stars from our Earth, blinking with a regular rhythm, though the light from pulsars does not actually flicker or pulse. On the 4th of July 1054 AD, Chinese, Japanese, Korean, and Arab astronomers reported an eye-catching event in the constellation Taurus. They saw a brilliant new beacon of light that blazed across the sky, shining brightly enough to be seen even in the daytime. This remained visible for almost 2 years. What they saw was the supernova's remnants of a massive hot giant star called the Crab Nebula that is estimated to have exploded some 7,500 years ago. A rapidly spinning neutron star rotating once every 33 milliseconds is embedded right in the center of that Crab Nebula. On the 18th September 2020, when NASA shared the breathtaking image of the Crab supernova captured by a Chandra X-ray observatory, the world was stunned. Now coming to the second case, if the collapsing core of a supernova is more massive, around 5 times the mass of our sun, gravity crushes it from millions of kilometers to just a few kilometers in diameter in only a few seconds. The temperature increases to as high as 100 billion degrees, turning the core into a black hole. A black hole does not have a surface. but it is simply a boundary in space called the event horizon beyond which we cannot see. Anything that passes beyond the event horizon is doomed to be crushed as it descends ever deeper and deeper into the gravitational well of the black hole. The gravitational pull of a black hole is so strong that it not only bends the path of light, but like a cosmic trap, keeps light from escaping. However, a black hole can literally light up the surroundings as long as it can gobble up the surrounding matter, converting the energy into light. This phenomenon has helped astronomers to picture the black hole. Now let's see what happens when you end up near a massive black hole. You will start moving faster and faster due to the gravity of the black hole. And once you go past its event horizon, you will be smashed into a point. The problem is that you cannot write home your experiences. Black holes were discovered only after the death of Einstein in 1955. Although his theory predicted the existence of the most exotic objects in the universe like pulsars, black holes, and even quasars, the highly luminous objects found in the center of galaxies. With the discoveries of these exotic objects, the once sedate universe has transformed into a cosmos filled with sources of titanic energies. Our universe is an intricately amazing place. The more we learn about the universe, the more we are intrigued. Based on X-ray observation, scientists believe that supermassive black holes may lie at the center of many large galaxies. A few years back, an ALMA radio telescope in Chile spotted a black hole roughly 100,000 times as massive as our Sun at the heart of Messier 87, a supergiant elliptical galaxy around 55 million light years from Earth. Astronomers started to build a network of telescopes spanning across many different continents to get an Earth-sized telescope so that this black hole could be pictured. Finally, in April 2019, the Event Horizon Telescope imaged the event horizon of that colossal black hole, which earlier people could only see in movies like Interstellar. Astronomers believe that the center of our Milky Way Galaxy contains a supermassive black hole called Sagittarius A with a mass equal to about 4 million suns. Now let me ask you to imagine two extreme cases. Number one, what if our solar system were somewhere closer to the center of our galaxy? We would have been sucked into the black hole, or we would have been surrounded by intensely hot plasma due to the supergiant stars where life cannot thrive. Number two, what if our solar system had moved towards the exterior of the arms of our galaxy? We will not have enough elements that are needed for life to exist due to fewer stars and fewer stellar explosions. This is because supernova explosions eject heavier elements like iron, carbon, and calcium necessary for life into interstellar space. Our solar system is seeded with heavier elements due to the several generations of supernova that exploded close to it. Astronomers are astonished to find that we are located in the right place in the Milky Way Galaxy. Milky Way Galaxy is a spiral galaxy with 4 major spiral arms having around 100 to 400 billion stars in the form of a thin disk around 100,000 light years in diameter and just a few light years in thickness. Our Sun is beautifully and strategically positioned in the inner rim of a minor arm called the Orion arm between two of the major arms. This position enables a clear-viewed cosmic window, allowing us to see the other parts of our galaxy and even beyond the hundreds of billions of other galaxies across the universe. Is this location of our Sun because of sheer luck or a mere fluke? Or is there an intelligent designer behind it all? The simplicity and the beauty of our existence reveal to us that we are not here by sheer luck, but someone so powerful has intelligently planned and crafted everything so that we will exist in this little world and also will be able to observe a considerable portion of this huge universe so that we can come to know about the designer behind the design.
Thus says the Lord, your Redeemer, who formed you from the womb. I am the Lord who has made all things, who alone stretched out the heavens, who by myself spread out the earth.
That's all for today. See you again in the next episode.